Hi. So this is super weird. Strange things are happening, but the learning must continue. So this seems like the best way to try to deal with the current situation. I'm going to try to make short videos to go along with the assignments, and then we can have discussions and, I don't know, emails and Google Hangouts or whatever it is as we go along. We'll figure it out as we go along. Um, but uh, this we're just going to jump right into this somehow, and we'll figure it out as we go. So as you can see, this is the slideshow for the evidence of evolution. We're learning about evolution. You just finished making an evolutionary tree, something called a cladogram, that shows the branching points from all those common ancestors. And that evolutionary history is kind of like a story. And so we want to have evidence for that story. We don't want it to like literally be a story. We want it to be a story based on facts. And so there are always pieces of evidence for all the things that we've been talking about. Unfortunately, we're not going to get to talk about anything specific like humans. Humans are always an interesting one to talk about. But this particular image shows the progression from our very, very early ancestors, something that looked a lot like a chimpanzee, and then forward through time, and it's forward through time to the modern human. And one of the things that this story tells us is that our brains have been changing, because in the original ancestor, it has a very small brain case, the skull part, right? And if you look, here's its eyebrows. It has almost no forehead. And this guy doesn't really have much of a forehead, and not much of a forehead. But if you keep going forward, you start to get bigger and bigger foreheads, because in the forehead part of your brain is something called the frontal cortex, and that's the part for thinking. That's the part for planning. That's the part that makes humans a lot more separate from all the other animals. And so just by looking at skulls of things, you can start to make these kinds of claims, tell these kinds of stories, right? So during this little section, we're going to talk about how do we know all the things that we know, or the basic idea behind them. Oh, this thing's not moving forward. That's awesome. There we go. There's a lot that goes into this. There's mountains and mountains of evidence. Of course, most of this falls into the realm of biology, but a lot of it is paleontology for fossils, which we'll talk about in probably a totally different video. But geology is the study of the earth and the study of rocks. And fossils are basically rocks at this point. And so understanding how rocks are formed, this picture right here is showing like a cross section of a mountainside. This is like a volcano with the lava part that goes up. And then this is like a mountain range, and you can see all the peaks and the valleys and what goes underneath them. And then there's these lines that show the layers of the rocks, because a lot of rocks called sedimentary rocks are laid down in layers, and those layers tell us about time, because the oldest layers come down on the bottom and the newest layers are on the top. And so if you find fossils down on the bottom, they gotta be older than the ones you find at the top. It's not always that simple, because sometimes earthquakes make things fold, and there's these breaks, which is what the black lines are trying to show on all these different pictures. And so it's not that easy, but there's people that study this their whole lives, that work on trying to unravel just this little tiny picture or piece of the story, right? But geology tells us about evolution, chemistry, the study of molecules. This tells us about evolution because you can track the way that the molecules have changed. This diagram gets a little bit too far beyond what we need to know about, but these are showing the different amino acids, which are the pieces that the proteins are made from, and how the first amino acids were very simple, and then they get more and more complicated as you go along, based on the timelines of how life evolved. And so people are looking at chemicals and where do they come from? And that lends evidence to what we understand about evolution. Physics is a study of the forces of the universe, and one of those forces is radiation. And we can use radiation coming from rocks to try to figure out how old the rocks are. The idea is that some of the atoms in the rocks are radioactive. And so here's this picture right here of all this rock with a bunch of red dots in it. And each of those red dots is a radioactive element. But over time, those elements turn into different elements. They release radiation and become something new. And so the blue dots are like the pieces that have already shut out the radiation. It's the empty shell after you fired the bullet, if you want to think of it that way. And so over time, it goes from red to blue to more and more blue as the molecules release their radiation. And if we can count the atoms, count the molecules, then we can see where they fit on this graph right here. And how many pieces are left gives us a point on the line, and then we can figure out how old they are. And so that lends a lot of evidence to our study of evolution. Geography, where are the fossils found? Again, I don't know how much we're going to get into this part, but this is when the continents were all close together and they find fossils of animals on different continents. And you're thinking, how can this lizard right down here be found in South America and Africa, or especially this plant, which is found on all these different continents? And how could it get into South America and Africa and India and Antarctica and Australia? Well, it doesn't make a lot of sense unless all these continents were really close together. And so that goes to the idea that there's been a lot of time that has gone by for all this stuff to happen. And we can reconstruct the history based on that kind of evidence. There's math that if you were in AP biology, you would learn some math that goes along with this. But I won't get into it here, but it helps us to understand how evolution works. So evolution has a lot of evidence to support it. It will probably always remain a theory because evidence isn't foolproof. And the only way to really tell is to go back in time. And we can't do that. But we can keep making the best picture possible using the best evidence that we have. And as we find more and more evidence, our story gets better and better. And so the next couple of videos will be about some of the different pieces of evidence that we have. As we go through the videos, there will be a worksheet for you to fill out so that you have something to turn in eventually. But more on that later. So that does it for this one.